right, guys, so we're going to do just the first page, front and back, first two pages of this worksheet for this video. I wanted to list out a few things that you need to study because it's been a while since we used some of these formulas. So to find the vertex of any quadratic, first of all, a vertex is hk. And to calculate h, remember you can do negative b over 2a. So this is assuming that that the quadratic is in its general form, which is like number 1 and 2. That finds the x coordinate or the h value, and then to find k, you plug in whatever that answer is. Standard form equation is also known as vertex form. So when I'm asking for the standard form equation, that's not the general form like number 1. That is y equals a times x minus h squared plus k. Axis of symmetry should always be a vertical line, x equals, and it's whatever the h coordinate is of the vertex because the axis of symmetry goes through the vertex. And then just make sure you know how to find a max and min and an intersection on your calculator. I don't have a calculator accessible on this computer right now, so I can't show you, but if you're having trouble, make sure you're coming prior to test day to figure that stuff out. We've been using those features for a while now. All right, so graph this quadratic function, fill in the missing information. So I like to start by doing the vertex. Some of you completed the square on your quiz, but you were making mistakes doing that because it's harder. So I would find the vertex first. H is the opposite of b over 2 times a. Negative 1 over 1 is negative 1. K is f of negative 1. So 1/2 times negative 1 squared plus negative 1 minus 4. 1/2 minus 1 is negative 1/2. Negative 1/2 minus 4 is negative 4.5. You could make that negative 9 over 2, but it doesn't really matter. I think when you're graphing points, it's better to think of the mixed number version because you're more likely to plot it accurately. So we can plot the vertex, negative 1, negative 4 and a half. So right here roughly. Standard form equation. Make sure that if this is f of x, you're writing f of x equals. And you shouldn't have any work to do for this, no calculation if you've already found the vertex. Standard form, remember, I'm just filling in this form right here. So now I do have to remember there's a coefficient of 1/2. That's the a that's out in front. So put the 1/2 in. And then it's x minus h squared plus k. And that's it. That's standard form. The axis of symmetry equation is x equals negative 1. You could choose to draw in the axis of symmetry if you want to. That's not required. But just to remind you what it is, it's cutting the parabola in half. To find the zeros for this function, you should be setting the function equal to 0. Now, anytime I have a fraction and I'm trying to solve an equation that's equal to 0, I want to get rid of the fraction. I'm going to multiply both sides by 2. 2 times 0 is still 0. This becomes x squared plus 2x minus 8. And then that's easier to factor. So x plus 4, x minus 2. The zeros are negative 4 and positive 2. So positive 2, negative 4. Oh, wait, what did I just do here? Negative 4 and positive 2. Oops, I didn't go far enough. Okay, I could tell something was wrong because this is not symmetric. So I accidentally, when I plotted 2, I didn't go from 0, 0. So here we go. This is symmetric. Those are both the same distance away from that axis of symmetry. So that's a good reason to draw that in. The y-intercept is when you plug in 0 for x, find f of 0. That's going to make this 0 plus 0 minus 4. So you can plot that. And it's weird to have a parabola that doesn't have symmetric points, so just hop a point across here so that you have a nice even amount of points there on either side anyway. And sketch in your parabola. Is f of x concave up or concave down? Remember, concave down looks like a frown. Concave up looks like that. I don't have a good rhyme for that. So this is f of x is concave up. And anytime, you don't even have to look at the graph. Anytime a function is concave up, that means that the rates of change are increasing. Rates of change are increasing. If you can remember that, if you can kind of like drill that into your memory, that's going to be really helpful when you get to calculus next year too. You can test that theory, by the way, figure out some slopes and just verify that it's not that the slopes are getting steeper, that the numbers for the slopes are increasing. They're going from negative to 0 to positive. Those numbers are increasing. All right, so next one, find the vertex. H is opposite of B over 2A. It's negative 1 again. K is f of negative 1. Negative 2 times negative 1 squared is 1. Minus 4 times negative 1 plus 3. That's 2 plus 3 is 5. So I'm going to plot negative 1, 5. There's our vertex. Standard form equation, look at the a value that should be out in front. Make sure it's an equation. I emphasize that because a lot of you didn't do that on your quiz. F of x equals negative 2 times x minus h squared plus k. So I am not completing the square at all on this entire review. Complete the square is nice because it's where a lot of our formulas come from, but it's not nice in that it's kind of hard to use. We might as well just use the formulas. Axis of symmetry, x equals negative 1. Again, you can draw that in. I'm going to because it helps me catch a mistake when I was plotting my zeros. To find the zeros, now I don't like trying to factor if x squared is negative, so I'm going to say, okay, multiply or factor a negative out. I guess you could look at that. And then does this factor, I don't think it's going to work. There are no combinations of 2 and 3 that are going to give us 4. So whether you use your original equation for quadratic formula or whether you use your factored out version, it doesn't matter. So because this doesn't factor, I'm going to use this version. It doesn't matter. Either way, you get the same answers. So negative 4 plus or minus the square root of 4 squared is 16 minus 4 times 2 times negative 3 all over 2 times 2. That's negative 4 plus or minus square root of, so this is negative 4 times 2 is negative 8 times negative 3 is positive 24. 16 plus 24 is square root of 40. Square root of 40 simplifies, it's 2 radical 10. You can divide 4, 2, and 4 by 2. So negative 2 plus or minus square root of 10 all over 2. Now we're not going to plot those points. We don't have a calculator, so it's kind of hard to estimate what those decimals would be. For the y-intercept, f of 0 is 0 minus 0 plus 3. So 0, 3 is something we can plot and hop across the axis of symmetry. So there's 3 points. Someone asked in class today, can I just do 3 points? Is that good enough? I would like to see one more set of points just so that you're not plotting, you're not trying to figure out what decimal this is. And we should be familiar with a negative 2x squared graph. Like, how has that been stretched? So from the vertex, normally an x squared graph, a negative x squared, you would go over 2 and down 4. But if it's negative 2x squared, you're going to go over 2 and down 8. So that's why I plotted these extra points, because when I connect these through, that sort of gives me whatever decimals these x-intercepts are, that's what this calculates out to. So it's just a bit more accurate. I wouldn't count off if you only graph 3 points unless the points where you cross the x-axis are way off. Like if you sketched it in and were kind of wild about it and you're going through completely different decimal areas, then that would be incorrect. Domain and range, you should get this by looking off of the graph. The domain is all reals. The range is from negative infinity up to the top, which is 5. So I'm pulling back some chapter 1 type questions. We're going to do that all year, kind of cycle things through, because that's how our AP test will be set up, just kind of keeping all of this fresh in your mind. All right, I'm going to do this next page, and then we will stop here for this video. For each table, determine the degree of the polynomial function. So we did this with linear and quadratic. We had one question in AP Classroom, but I didn't require that assignment. So if you missed this, the idea is that as soon as you do first, second, maybe you have to do third and fourth differences, whatever set of differences is constant, so you get the same number every time, that is what degree the polynomial is. It's connected to derivatives and the power rule. We don't need to get into all of that, but we're just looking at differences. So we can do this because all of the x values are consecutive x values here. So find the first differences for this first one, which means subtract 20 minus 87. So if I subtract 20 minus 87, I get negative 67. And I don't have anything right here. 3 minus 20 is negative 17. 0 minus 3 is negative 3. Negative 1 minus 0. 12 minus negative 1. 75 minus 12. So this is not linear because we're not getting the same differences here. Find the second differences, meaning subtract negative 17 minus negative 67. That's positive 50. Negative 3 plus 17 is going to be 14. Negative 1 plus 3 is going to be 2. 13 plus 1. 63 minus 13. So this is kind of interesting. It's like symmetric right here. That doesn't always happen. It's not quadratic because the second differences are not constant. Find the third differences. Nothing to subtract. There. 14 minus 50 is negative 36. 2 minus 14 is negative 12. 14 minus 2 is 12. 50 minus 14 is 36. That's not constant. Negative 12 minus negative 36 is 24. 12 minus negative 12 is 24. 36 minus 12 is 24. So the fourth differences are constant. That means that this is a degree 4 polynomial. Again, it has to do with derivatives, and if you have degree 4, it would take you 4 derivatives to get down to a constant. But again, I don't want to talk about the calculus part of it. This is just our pattern for polynomials. So you do that for each one. Negative 13 minus 1 is negative 14. Negative 27 minus negative 13 is negative 14. If you do the math on this, you're going to keep getting negative 14. So because the first differences are constant, this is degree 1, excuse me, also known as linear. And for our third one, 72 minus 98 is negative 26. 50 minus 72 is negative 22. 32 minus 50 is negative 18. 18 minus 32 is negative 14. 8 minus 18, negative 10. 2 minus 8, negative 6. Not linear. Negative 22 plus 26 is 4. Negative 18 plus 22 is 4. So again, you're going to get 4s for all of these. So because the second differences are constant, that makes this degree 2 or quadratic. All right. Solve each quadratic equation using the most efficient method. I had this on our quiz, and I was a bit surprised by like how inefficient some of you were being, like just doing quadratic formula no matter what, or factoring without getting something equal to 0. So, okay, so here are the rules. First, the quadratic must be equal to 0 if you're going to factor or use quadratic formula. So first off, make sure you get that equal to 0. So here we go. 3x squared plus 5x minus 12 equals 0. You should try to factor before you do quadratic formula. We factor every week. You factored every week last year. You should be pretty good at factoring. Even if you're not great at the speed quizzes, you are good at factoring. So give it a try. It might take some trial and error. This is the way I factor trinomials. I'm guessing. I think it's 4 and 3. Double check. 3 times 3 is 9. 4 times x is 4x. I need to get 5x, which will happen if I put a plus here and a minus over here. Okay? So what are the solutions? X equals 4/3 and negative 3. I would say factoring is more efficient than quadratic formula for that one. Now, number 7 is already equal to 0, but I can't factor. There's no combo of 3 and 5 that's going to make 1 or negative 1 in the middle. So this one does need quadratic formula. Positive 1 plus or minus square root of negative 1 squared is 1, minus 4 times 3 times 5, all over 2 times a. The square root is 1 minus negative 4 times 3 is negative 12, times 5 is negative 60. So 1 minus 60 is negative 59, all over 6. And the only thing to simplify that is 1 plus or minus I radical 59, all over 6. Okay, most efficient way for number 8 is to isolate the squared piece, so divide by 2. So if you're using square root method, isolate the squared. So x plus 3 squared equals 7. Then you can square root both sides. You have to remember the plus or minus. And then you subtract 3. The long way to do number 8 is to FOIL out x plus 3 squared, multiply by 2, subtract 14, do quadratic formula, and get all the way here. But again, you want the most efficient method so that you're not wasting a bunch of time. Given a vertex and a point, find the standard form equation. Again, this is y equals a times x minus h squared plus k. The vertex is hk. The point is xy. Plug in the pieces and solve for a. So negative 2 equals a times 5 plus 3 squared plus 4. Subtract 4. 8 squared is 64. Divide by 64. Reduce. You can divide by 2. Once you know a, you know your equation is y equals negative 3 over 32 times x plus 3 squared plus 4. Same thing for this one. 1 equals a times 8 minus 6 squared minus 7. Add 7. 2 squared is 4. Divide. Write your equation. Okay, last 2 problems for this video. Let 2 numbers be integers. The sum of the first number and twice the second number is 24. So the sum of the first number plus twice the second number is 24. Find the maximum product. So what's the product? Multiplying the 2 numbers together. I don't want 2 variables, so I solve the sum equation. Oops. For x, because that's easiest. Plug that into my product for x. So x is 24 minus 2y times y. Because this is not a calculator problem, I'm going to distribute the y so I can do the vertex formula. The maximum will be the vertex. Instead of h equals, it's y equals negative 24 over 2 times a. Negative 24 over negative 4 is 6. I want the maximum product. So, but I don't want to plug 6 into this. I could get it that way, but I could also say figure out x, 24 minus 2 times 6, and which is 12. And the maximum product is 6 times 12, which is 72. Okay, I changed number 12. I think I forgot to say this in my morning class. So let these two numbers be real numbers. They're not integers. The difference between triple the first and twice the second, 3x minus 2y, that difference is 1. Find the minimum product. Minimum product is x times y again. This one doesn't have as nice of a thing to solve for. I'm going to solve for x again just because I get to add 2y instead of subtracting and having negatives. When you divide by 3, it's 1/3 plus 2/3 y. 1/3 plus 2/3 y times y is 1/3 y plus 2/3 y squared. Find the minimum, which is the vertex again. Y equals negative b over 2a. Negative 1/3 divided by 4/3 is like times 3/4. Again, find x. Instead of plugging this in a product, just find x. It's usually easier. 1/3 plus 2/3 times negative 1/4 is 1/3 minus 1/6. 2 over 6 minus 1 over 6 is 1 over 6. So the minimum product is negative 1/4 times positive 1/6, negative 1/24. All right, I'm going to stop there for this video. I'll have another video for the next set of pages.